Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Vector Databases, the super fast index for your AI's library. Imagine AI as a super smart student. To answer questions or create new things, this student needs to read and understand a vast amount of information, text, images, sounds. The faster and better it can find relevant information, the smarter and more useful it becomes. But how do you organize a library with billions of books, so the student can find exactly what it needs instantly? That's our challenge. You, as a developer, are probably familiar with databases like SQL. They're amazing for structured data. What's John's phone number? Or list all products over $50. But what if AI wants to ask, find all images that look similar to a cat playing a piano, or give me documents that talk about the same concept as renewable energy, even if they don't use the exact words renewable energy? Traditional databases struggle here because they look for exact matches or specific categories, not for meaning or similarity. It's like trying to find a book about love in a library organized only by author and title. Think of a vector as a special numerical fingerprint for anything a word, a sentence, an image, a song. It's just a list of numbers, like 0.1, minus 0.5, 2.3, 0.9, . The magic is that items with similar meanings or characteristics will have vectors that are close to each other in this numerical space. For example, the vector for cat might be 0.2, 0.4, 0.1, and kitten 0.25, 0.38, 0.09, while car would be 1.8, minus 0.2, 5.0, . From a developer's perspective, instead of storing a string cat, you're storing an array of floats that represent cat to the AI. So, how do we get these magical number lists? Vectors. That's where embeddings come in. An embedding model is a special AI program that takes your human-readable data, text, image, audio, and translates it into a vector. It's like a universal translator that converts the quick brown fox into 0.3, minus 0.7, 1.2, and an image of a dog into a different set of numbers. This translation process ensures that similar concepts get similar numerical representations. As a developer, you'll often use pre-trained embedding models, APIs, to generate these vectors for your data. Now that we have these numerical fingerprints, vectors, for all our information, how do we store and search them efficiently? That's the job of a vector database. Imagine a library where instead of organizing books by author or title, they're organized by idea. All books about love are in one section, books about adventure in another, and books about friendship are close to love. A vector database stores these numerical fingerprints and is specifically designed to find other fingerprints that are similar extremely fast. It's not just storing numbers, it's organizing them by their inherent meaning. As a developer, you'll mainly interact with a vector database by inserting your generated vectors and then querying for nearest neighbors. When you give it a vector, e.g., for cat playing piano, it uses advanced algorithms, like approximate nearest neighbor search or ANN, to quickly scan its vast collection of vectors and return the ones that are numerically closest. This closeness directly translates to semantic similarity or looking alike. This is far more efficient than checking every single item one by one, which would be impossible for large datasets. For developers building AI applications, vector databases are a game changer. Context for LLMs. RAG. Asterisk give large language models, like ChatGPT, access to asterisk your specific data so they can answer questions based on up-to-date, accurate information, beyond their training data. This is called Retrieval Augmented Generation. RAG. Semantic search. Asterisk build search engines that understand what users mean, not just the keywords they type. Recommendation systems. If you like this, you'll like that. Find items, products, movies, similar to what a user enjoys. Speed and scale. Asterisk they're built from the ground up to handle billions of vectors and deliver lightning fast. Similarity searches, which traditional databases cannot. Vector databases are already powering many of the AI features you use. Asterisk ChatGPT's long-term memory and real-time knowledge. Asterisk when an LLM retrieves information from an external source to answer a query. E-commerce product recommendations. Customers who bought this also bought. Reverse image search. Asterisk upload an image and find similar ones. Personalized content feeds. Asterisk news articles, social media posts, or videos tailored to your interests. Fraud detection. Asterisk identifying unusual patterns of behavior. They are the backbone for giving AI a powerful, dynamic memory and understanding of diverse data. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.